A very good morning, good afternoon, or good evening to our Dr. Masdida, and our teammates. The thing that we are going to present for our assignment is molecule building and analysis. We are from Group 6, and my name is Ding Zongjing, and my teammates are Farah Isniza as our leader and Nurul Fatning as our teammate as well. The chemical substance that we have chose for our project is calcium carbonate with chemical formula CaCO3. So I would like to introduce the chemical structure of calcium carbonate. Calcium carbonate it has a molar mass of 100.0869 gram per mole. Besides that, the calcium carbonate is polymorphous, which means it exists at different forms with the same chemical formula.
Last but not least, it exists as minerals aragonite, which is orthorhombic, calcite, which is trigonal, and wetterite, which is hexagonal, and with several forms, which is normally comes from the precipitation of marine life or eggshell.
So this is a digital model of the calcium carbonate. So as you can see, the gray sphere it represents a calcium ion, while the black sphere it represents a carbon atom, and the red sphere it represents the oxygen. So this is a model that we have built. So the green sphere represents a calcium ion. The green sphere it is a carbon atom. Oxygen with double bond it is oxygen atom, and the red sphere with single bond it is a O- ion. So this is a 2D model of the calcium carbonate. As you can see, it is made from calcium ion and carbonate ion with charge of 2-. Calcium carbonate, it is an ionic compound, and there is ionic bond present, which is a force of attraction between the calcium ion Ca2+ and polyatomic ion of carbonic ion CO3 2-. But there is covalent bond present inside the calcium carbonate as well. It present inside the carbonic ion. So the covalent bond, there is single bond between carbon and O- ion, while there is a double bond between the carbon and oxygen atom. So how is the calcium carbonate structure formed? So we start from the calcium ion. Calcium ion is from the calcium atom, which lose 2 electrons by forming ionization energy, and it will form the Ca2+ ion. While for oxygen, it will undergo electron affinity to form oxide ion, which is O- ion, by donating an electron, or valence electron, by forming a double bond with an oxygen atom and 2 single bonds with 2 oxide ion, O- ion respectively. So because there is 2 oxide ions, so it will form an overall charge of 2-. And the scientist has discovered that instead of different bond length, but all of the bond length are of the same length. This is due to the resonance effect between the carbon and oxygen. So this is the electron configuration of calcium, oxygen, and carbon. While for the valence electronic configuration, for calcium, it is 4s2. Carbon, it is 2s2, 2p2. Oxygen, it is 2s2 and 2p4. And now I would like to introduce the orbital diagram. For the carbon, it will undergo excited state by one of the 2s electron in 2s orbital excited to 2p orbital. And one of the 2s and 2 of the 2p orbital will undergo sp2 hybridization to form sp2 hybrid orbital. But for orbital diagram of O- ion, it does not undergo the excited state. And all of the 2s and 2p orbital will undergo sp3 hybridization to form sp3 hybrid orbital. Last but not least, it is the oxygen atom. Oxygen atom, one of the 2s orbital and 2 of the 2p orbital will undergo sp2 hybridization to form sp2 hybrid orbital, leaving a 2p atomic orbital on the top of the energy. So this is a diagram for the overlapping of orbital. As you can see from the diagram, there is a pi bond which is formed between the carbon and oxygen atom inside the double bond, while there is 3 sigma bond, which one of it is from the carbon and oxygen atom, and 2 of them are from carbon and O- ion. So the pi bond it is from the side-to-side overlapping, while the sigma bond it is from the head-to-head overlapping. And now I would like to introduce some of the shape or bond angle or carbonic ion. It is a trigonal planar structure, and the bond angle it is 120 degree. While there is 3 sigma bond and 1 pi bond inside the structure, and last but not least, there is a double bond pair between carbon and oxygen atom, while there is 2 single bond pair between the carbon and O- ion. So how are the atoms are going to be related to their positions? Firstly, we look at the calcium atom. As you can see, the calcium atom, it has 20 proton. So it is from the group 2 and period 4 with 2.8.8.2. It has 2 valence electrons and 4 electron shells. And for the carbon, it has 6 proton, which is from a carbon group. So it is from group 14 and period 2. It has 4 valence electrons, so it is from group 14, and it has 2 electron shells, which is from period 2, with the electron arrangement of 2.4. Last but not least, oxygen. Oxygen it is from chalcogen with group 6 from group 16, period 2, and it has 8 proton. So it has 6 valence electron and 2 electron shells with electron arrangement of 2.6. And now I'm going to pass on the next to our next presenter, Nurul Fatmi.
Okay, next we will discuss about the trend or the patterns in few properties. There are some physical properties of element which are atomic radius, ionic radius, ionization energy, electron affinity, electronegativity, melting point, and boiling point. So, first of all, atomic radius. Atomic radius for calcium atom have biggest atomic radius and oxygen atom have smallest atomic radius. For the down the group trend, calcium has a bigger and larger atomic radius than carbon and oxygen. This is due to the increase in the number of shell between the nucleus and the valence electron. Within calcium atom, the electrons in the inner shells are much closer to the nucleus than the valence electron compared to carbon and oxygen atom. Hence, effectively shield it from the positive charge of the nucleus. The effective nuclear charge decreases because the average distance of the valence electron from the nucleus increase with the principal quantum number, which is n. The radius increase on moving down the group. For the across the period, carbon and oxygen stated in the same period, which is period 2. Carbon have larger atomic radius than oxygen. The electrons are being added to the same shell at about the same distance from the nucleus. Within oxygen atoms, the inner shell electrons shield the valence electrons more effectively than valence electron in the outer shell shield to each other compared to carbon atom. The effective nuclear charge for the electrons in the valence shell increases. The larger the effective nuclear charge, the stronger the hold of the nucleus on the valence electron and the smaller the atomic radius. Okay, next, ionic radius. For the down the group on descending a group, there is an increase in the ionic radius. Calcium have larger ionic radius than carbon and oxygen. For the across the period, oxygen have larger ionic radius than carbon. Oxygen have lower nuclear charge than carbon. For a given number of electrons, the lower the nuclear charge, the lower the force of attraction and the larger the ionic radius. In the same period too, the size of the anion are larger than cations. For ionization energy, down the group, first ionization energy for calcium is lower than oxygen and calcium, than carbon. I'm sorry. On descending a group, the atomic size increases. The attraction between valence electron and the nucleus become weaker. The valence electron is easily removed from the atom when enough energy is provided. Thus, the first ionization energies of the element decrease. For the across the period, first ionization energy for oxygen is higher than carbon. The shielding effect remains approximately constant, but the effective nuclear charge for the electrons in the valence shell increase. The attractive force for the positively charged nucleus for the negatively charged valence shell electron increase. As the result, the first ionization energy increase. Next, for the electron affinity. Down the group, electron affinity for calcium is lower than oxygen and carbon. Electrons are added further from the nucleus. The attraction force between nucleus and the added electron decrease. Electron affinity become less negative. For across the period, electron affinity for oxygen is higher than carbon. Electron affinity becoming more negative from left to right across a period as the affinity for electrons increases. The effective nuclear charge increases across a period. This increases the attraction of an atom for an additional electron. Next, electronegativity. For the down the group, electronegativity for calcium is lower than oxygen and carbon. The electronegativity decrease on going down a group. This is because the atomic radius increases from top to the bottom of a group. So, the effective nuclear charge has less ability to attract the electron due to the shielding effect of electron in the inner shell. Further across the period, electronegativity for oxygen is higher than carbon. The effective nuclear charge increases with the proton number. The ability to attract electron increases, thus there is a steady increase in electronegativity. Last but not least, melting points and boiling points. The melting and boiling points are not uniform. It depends on the structure and bonding of the element across the period. Melting point and boiling point for carbon is higher than calcium and oxygen. This is because carbon have the giant covalent structure, which each atom is strongly held by strong covalent bonds. The covalent bonds are rigid, strongly bonded, and difficult to break. In order to melt the solid, we need to break nearly all the existing covalent bonds between atoms. So large amount of energy is required. Meanwhile, calcium atom have metallic structure. So bonding in metal is called metallic bonding. It results from the electric attraction among positively metal ions and a sea of delocalized valence electron. Oxygen atom is the non-metallic element form the simple molecular structure. These simple molecule are held by weak van der Waals force in its molecular structure. The strength of the van der Waals force depends on the size of the molecule, which is its molecular weight. Next, the type of chemical bond present in calcium carbonate. So in our first presentation, my member have present about this chemical bond. Calcium carbonate have two types of chemical bond, which is ionic compound and covalent bond. I'm sorry. So for ionic bonding is between the calcium ion Ca2 plus and an ion is carbonate ion CO3 2 negative. So for covalent bond, as CO3 2 negative is made from carbon and oxygen atom held together by covalent bond. Next, about how the bonding influence the molecule's properties and behavior. So for properties for ionic bonding, first ionic compound often have high melting and boiling points. This is due to the strong electrostatic forces. High temperature are required to overcome the attraction between the positive and negative ion in ionic compound. Therefore, a lot of energy is required to melt ionic compound or cause them to boil. Second, ionic compound conduct electricity when dissolved in water. When ionic compounds are dissolved in water, the dissociated ions are free to conduct electric charge through the solution. Third, ionic compounds are good insulator. Ionic solid do not conduct electricity very well because the ions are bonded so tightly to each other. The differences between second properties and third properties. The second property it mentioned when dissolved in water, it will conduct electric charge. Meanwhile, the third properties, it focus on the ionic solid. Fourth properties, ionic compounds are hard and brittle because the positive and negative ion are strongly attracted to each other and difficult to separate. However, when pressure is applied to an ionic crystal, the ion of like charge may be forced closer to each other. The electrostatic repulsion can be enough to split the crystal, which is why ionic solid also are brittle. Properties for covalent bonding. First, low boiling and melting points. The molecules of covalent compounds are held by weak intermolecular forces. Thus, a very small amount of energy is required to break the bonds between two or more molecules. Second, covalent compounds do not conduct electricity. This is because covalent compounds do not have charged particles capable of transporting electrons. That's all from me. I will pass it to my Farah Isniza.
Okay, so now I will present the real-world application of calcium carbonate. Okay, so as we all know, calcium carbonate has a lot of uses, especially in our daily life. Okay, so for example, we use calcium carbonate in construction and building material industry. For example, as production of cement for buildings. Secondly, in healthcare industry that works as an antacid. And thirdly, in manufacturing industry for paper production. Okay, so for production of cement, calcium carbonate is used in building cement due to its chemical property of decomposition under high temperature. In the process, calcium carbonate undergoes thermal decomposition in a kiln to produce calcium oxide and also carbon dioxide. A kiln is a thermally insulated chamber, like a type of oven, that produce temperatures sufficient to complete some process, such as hardening, drying, or chemical changes. Kilns have been used for millennia to turn objects made from clay into pottery, tiles, and bricks. So after this process, the decomposition under high temperature, the calcium oxide later will react with silica, alumina, and iron oxide to form compounds known as calcium silicate, calcium aluminates, and calcium ferrites. These compounds will later undergo a hydration process to create a hardened material known as cement. After that, antacid. In making antacid, calcium carbonate used its chemical property of neutralization of stomach acid. Since calcium carbonate is an alkaline, when it reacts with the excess hydrochloric acid in the stomach, they will form calcium chloride, carbon dioxide, and water. This reaction results in neutralization of excess stomach acid by the calcium carbonate with hydrochloric acid, thereby raising the pH level in the stomach. As we all know, our stomach has hydrochloric acid to digest our food. But when it comes to a situation where it has excess the supposed amount, we will have like a nausea or like stomach ache. So we will take medicine such as antacid because the reduction in acidity helps alleviate symptoms like heartburn, indigestion, and upset stomach. And after that, lastly, filler material of paper. In this process of manufacturing paper, calcium carbonate used as a filler material to enhance the quality of the paper. Before calcium carbonate was added, the process undergoes a stage called pulping. This process breaks down the limestone and other material into a slurry or pulp with mix of water to separate them from impurities and other minerals. Calcium carbonate is then mixed with the pulp along with other additives like starch, sizing agents, and additional pigments to enhance paper's properties like brightness, smoothness, opacity, printability, and strength. So in this case, calcium carbonate was used to be a filler material because it has like a good composition to make the things become better. So I think that's all for the real world application. And this is our reference that all the website and also the document that we used in completing this task. I think that's all from us. Thank you.